Hey everyone, welcome to this session at Connect on Azure Functions. I'm Jeff Holland. I'm a Senior Program Manager for the Azure Functions team. And over the next little bit, we're going to talk about what Azure Functions is. I'm going to share with you how you can get started building Azure Functions through a number of different tools that we provide so that you can start taking advantage of the power of Azure Functions and seeing what all the excitement is about. So getting started quickly, I do want to talk a little bit about what Azure Functions is and how you can use it in your day-to-day development. So Azure Functions at its core is serverless compute. And if you're not familiar with that term serverless, it's okay. We'll go into it and I'll briefly describe it in just a second. But really what it means is that you can provide your code, just a little bit of C# code or Node, Java, you can see here. You publish that code to Azure. And when an event happens, whenever we need to run that code, Azure will automatically take care of everything to run that code at scale in the cloud. So Azure Functions is perfect for if you need some script or API or some job to run in response to some event. You simply write that code or logic, you publish it to Azure, and the rest is taken care of for you. So we're going to talk a little bit about how you can get started building Azure Functions, some of the new features that we've just been releasing and have been released, as well as talking to you about some of the development tools that you can take advantage of. So we'll talk about Visual Studio Code, and even RCLI. So before we go deeper into Azure Functions, I do want to briefly define serverless if you're not familiar with the term, because this is something that has been getting a lot of hype, a lot of energy throughout the entire industry right now. It's definitely something that if you're not familiar about what serverless is or how it can improve your development processes, you're going to want to keep an eye on this. We talked about it briefly kind of in the introduction to Azure Functions. But what serverless is first and foremost, it's an abstraction of servers. So if you think about building and publishing an application into the cloud, all of the things that traditionally you had to manage and deal with, whether that was, which operating system do I use, and what do I do if I get a lot of requests and I need to increase capacity? What if nobody's calling my application? How do I make sure that I'm utilizing that compute appropriately? These are all valid questions, and many people have spent a lot of time making sure that they're optimizing on all of those different factors. And with serverless, all of those server-based decisions are abstracted away from you. So it's serverless because you as a developer no longer have to worry about the answers to those questions. They're all managed automatically for you from the service. Another aspect of serverless is that it's an event-driven process. So in order for us to spin up resources on demand for your Azure function to run, for your Azure Logic app to run, whatever serverless service you may be using, we need some event. And sometimes people hear that event-based processing thing and they get a little worried. They're like, oh, does this mean I need to start using event listeners or taking advantage of patterns that you may not be using? And it's nothing that complex. Really, Azure Functions just needs to know what is the thing to let us know that your code needs to execute. So events can be very, very flexible. It could be every day at 5 o'clock or at the end of every month or whenever you post a message to a queue or to a topic, or even things like whenever I add a customer into Salesforce or whenever I get a new email. There's so many different events, these things that happen that you may want to run a little bit of code. And this is exactly what serverless is designed to do. And the last piece that's really appealing is that it's micro build. So you will only ever be charged for the compute that you actually utilize. So that means that if nothing is running, you're not paying anything for it. This is fantastic because, let's say you do want a function to run on a new email and you don't get any emails over, some holiday or something. You're not charged at all for that function when it's not being utilized. And then if maybe the next day you get 1,000 emails all within an hour, that's totally fine. The function will scale up automatically, run that function for each email, and everything just works. So that's a little bit about what serverless is. You can probably understand some of the benefits that you get for taking advantage of serverless technology as well. So first and foremost, it's reduced DevOps. You don't have to spend as much time developing your solution because so much is managed for you by the service, as well as operating your solution. So if you have peak traffic loads and you have different aspects that happen, Azure Functions can dynamically and elastically scale to meet demand. This allows you as a developer to just focus on the business logic. You don't have to worry about making sure you're utilizing the right framework or tools. You just write the piece of logic that's necessary for this process, and everything else is taken care of for you, which first and foremost kind of provides this fast time to market. If there's one thing that I'd want you to take away from what do I get from serverless, it's that increased velocity that you can take advantage of. When you're not worried so much about managing all of these different aspects, you can really start to build and ship applications in a fraction of the time. So double clicking a little bit onto Azure Functions, I do want to share with you some of the event sources that you can attach your Azure function to, as well as data sources that you can push data to and from automatically. So you'll see here, this is a table. This has a number of the different triggers that are supported by Azure Functions. These are some of those events that you can automatically attach your code to run on. So it could be on a schedule. It could be on a web request, HTTP. If this was a serverless API, an HTTP request is going to come in. We'll execute and start running the code and do everything there for you. Storage, queues. One that we're excited to announce for the version 2 of our runtime at Connect is Cosmos DB triggers, so that you can run code whenever you're inserting documents into Cosmos DB. Now, one thing that's important to note, though, is that this list isn't comprehensive. You can extend this and trigger from sources outside of this list. We have many customers who are doing exactly that. The other two columns here, too, the inputs and outputs, these aren't necessarily triggers that will invoke your function. These are just out-of-the-box bindings. Bindings are what we call them, that allow you to pull data in or push data out to any of these sources as well. So if, as the result of one of your functions, you wanted to create a document inside of Cosmos DB, instead of you having to go understand the SDK and how those different pieces in Cosmos DB worked, you can simply take advantage of that binding out of the box and push data, and the service will automatically go create the record for you. So I'll be showing you all of this today as we go throughout the session, but it is worth having an understanding here. Before we go into demos, there is just one more aspect I do want to hit on, which is some of the customer use cases and excited customers we get using Azure Functions. So Azure Functions just became generally available about a year ago, last November. One of the exciting use cases that have come out since we've become generally available is from Quest. And Quest actually provides tools and management capabilities for different enterprise organizations around IT. So they wanted to build this software as a service solution to enable those tools to their enterprise users. And in building this, they started to leverage Azure Functions and serverless technology. And I love this quote from Simon, who's their lead Azure architect at Quest. And he talks about how they cut what used to take 6 to 8 months in development to about 1 or 2 months with Azure Fully Managed Services. So this reduces their time to market by 2/3, so they can get and innovate on new features in just weeks. And this is really what the promise of serverless is all about, enabling you to build and ship your features in a fraction of the time so that you can be more competitive, so that you can focus on the things you want to focus on, allowing Azure to provide those capabilities out of the box. So if this is your first function or your 50th function, I do now want to quickly show a demo of how anyone can get an Azure function up and running in just a few seconds. So let's go ahead here, and I'm going to switch over to the Azure portal. So I'm looking now on my screen. This is the Azure portal. This would work for any account, whether it's a free trial or MSDN subscription, whatever that might be. And if I ever want to create a function, I just have to simply come in here to create a new resource. And you'll notice here, actually right on the front page, we have a serverless function app. So I can go ahead and create a function. I'm going to give it a name. This needs to be globally unique. So we'll just say, my email address and then connect live. I choose a subscription and a resource group to organize this function in. One thing worth calling out is that we do in Azure Functions provide 2 hosting plans. So the consumption plan is also called the serverless plan. This is the one where you don't pay anything unless it's running. We'll dynamically allocate and consume resources as your function demands it. But if you want, you can also publish your Azure function into an app service plan used for like websites or backend APIs as part of app services. In this plan, your function actually executes for free, but it will be sharing and consuming those resources in your app service plan. So if you already have a website or an API, you can choose to host your function that way. Or if you just want those serverless benefits and will spin up and consume the resources as you need, you can choose that consumption plan. I'll go ahead and choose a location. We use a storage account in Azure Functions to do things like store your code or your binaries, as well as to do things like storing logs and any state that you might need. The last one here, I'll show it later on in this session, but I can also enable application insights. And what this is going to do when I turn this on, and I would honestly really strongly recommend always turn this thing on, is it's just going to give me some really rich insights and analytics into how my function is performing. So it's super easy to enable it. I just switch this to on, and I'm done. So let's go ahead now. We've configured all I need to configure for this Azure function, and I'll go ahead now and choose to create this. Now it only takes about 30 seconds to a minute to spin up that storage account, get everything ready to go. But I've actually gone ahead here and spun one up just a few minutes ago, which we'll use to show you some of the tools here. So I've opened up an Azure function. This is an empty Azure function app. And an Azure function app can contain many functions. So you'll notice here on the left here, I have my list of functions, which is empty right now. And a few things I'll just call out. You can manage how this function is running, start it, stop it, get the publish information if I want to publish this outside of one of our tools. I also get a lot of features here. A few that I'm going to call out here because we'll be using them in later demos. I can actually manage some of my application settings. So I'm going to go ahead and open this one up and show you what this means. You'll notice here I have a number of different application settings. Most of these were set automatically for me, which are kind of the environmental variables of what will be used when my function runs. So a few to call out here, I've got my storage account, and it has my storage account information that I selected when I created this thing. You'll notice the function app we created before is done now. It has the version of my function runtime, and I can also add my own application settings as well. So it's important to know that this is here because it will come into play as we move into Visual Studio and other tools moving on. All right, so now that we know what a function app is, that we have these different application settings and a number of these platform features as well, which I won't go into here, but it's worth poking around and learning more about each one of these does. Let's go ahead and create a function. So I have here my functions list, which is empty, and I'm just going to go ahead and click this plus sign to create a new one. And since I don't have any functions yet, it's actually giving this simplified template page. And you'll see here I can choose any of those languages that I mentioned on the previous slide. In this case, let's just do an Azure function that can be invoked over the web. And we'll leave this as C# and go ahead and create the function. So just this quickly now, we have a function created. It's now showing us this template code. I'll just explain briefly what it's doing. It's getting an HTTP request. And when I get that request, I'm checking two things. First, I'm checking the query parameters, and I'm seeing if there's a name query parameter. And I'm also checking the body of the message, and I'm seeing if there's a name attribute in the body. And if any of those names are provided, I'll actually respond back with this friendly hello. And if nothing's provided, I'll respond back with a bad request. So simple enough. What's great here is that I could continue to actually edit and write my function in line if I wanted to do. I can go ahead and save any changes that I make right here in the portal. You'll notice here when I saved it, you actually get some logs in real time that you can manage. And I can even test this as well, all from the portal. So let's go ahead and test this Azure function now. I'm just going to click this Run button, and it responds back with Hello Azure. If I want to go ahead and change this to Hello Connect, I'll go ahead and run it, and it's there. You can see that this is running now. In just that small amount of steps, I now have this publicly accessible web endpoint that now I can call to invoke this function. It's going to run the bit of code that I told it to run and respond back. And what's great here is that I haven't had to manage anything else on how this app is hosted and how this app is patched. It's just taken care of automatically for me. So now if all of you were able to write down this crazy cryptic code and call this function yourself, you could, and it would scale to whatever demands that has. So that's a little bit about building your Azure function. The one more thing I'll show you before we go into some more slides is there is this tab here called the Integrate tab. This enables you to configure those input or output bindings as you may want. So if I wanted to output something to storage, I could go ahead into this Integrate tab and set that up and get it all ready for me to go, look at documentation to help me get the code back into my function. So that tab is very useful for you as well in managing your function app. Okay, so now that you've seen a basic Hello World Azure Function app, let's go into some more advanced scenarios and some more advanced dev tooling. So the first thing with Azure Functions is it's very, very flexible. Whether you're writing an Azure function very quickly and you're using the Azure portal like we just did, or you're getting into more complex dev cycles or more complex Azure functions and you want something like Visual Studio or Visual Studio Code helping, providing testing and breakpoints and all those other goodies that come with some of these tools. So we showed you the Azure portal. That works great. You can also use Visual Studio 2017. And if you choose that cloud work pack when you're installing Visual Studio, it comes with Azure Functions tools. In fact, with Connect, we've actually launched a new update to those tools, and I'll show you some of that in just a second. This is perfect if you're writing C# functions. In fact, I would say if you're writing any C# functions, you should be doing it in Visual Studio 2017. It gives you a much better experience than we can provide directly out of the portal. You get things like breakpoints. It will actually build and compile those DLLs and publish them to the cloud instead of using C# scripts, which is what the portal uses. So it's a great tool, perfect for that experience. There's also Visual Studio Code. So if you want to write your functions in Visual Studio Code, that's great too. You can write any function in Visual Studio Code. But just recently, in the last few weeks, we've actually rolled out an update with an extension published by Microsoft provided just for writing Node applications for Azure Functions. So go ahead in Visual Studio Code, head to the extension page, download that extension from Microsoft. It's going to give you a first-class experience for developing Node apps inside of Visual Studio Code. But like I mentioned, you can edit any Azure function inside of code. And then the last one, which is the most flexible, is the Azure Functions Core Tools CLI. This is currently distributed via NPM. But you can do all of your function operations, creating new functions, publishing functions to the cloud, managing or downloading settings from your functions that are already published. All of these capabilities are provided from the CLI for Azure Functions. Very flexible if you don't want to use any of those other options. Maybe you want to write your functions in Eclipse or in whatever tool, IntelliJ, that's fine. You can use the CLI to help you do that as well. There is one important note to call out, and if you're using our latest build of Azure Functions in Visual Studio, you'll want to take note of this, and that's that we have recently released the preview of the next version of the functions runtime. So that piece of code that's actually running your function, we now have the V2 available. It's in preview. And there are a few notable differences here that I wanted to call out, because as you create new functions in Visual Studio, it's actually going to ask you which version do you want to create this function on. So V1, it is the current generally available version of the Azure Functions runtime. That's the one that became generally available a year ago. It is built on top of .NET Framework 4.6, and one important call out of that is that it is not cross-platform. So you would need to do this development either in the Azure portal or on a Windows device. Now the V2 runtime is cross-platform, and that's because this is built from the ground up on .NET Core 2.0. So this gives us a lot of benefits. I'm doing all of my demos today from my Mac, and everything works great on functions on a Mac or on Linux or whatever device you want to do. We've also been able to make a few improvements and enhancements to Azure Functions with this new version. One of those pieces is we actually allow for language extensions so that your language workers can actually run independently of the Azure Functions host. So the first language extension that we've recently released is the Java language extension. So if you want to write Java Azure Functions, you'll need to use the V2 runtime. The Node runtime is actually a language extension as well, which isn't on this slide. The other important benefit of V2 is that we allow you to write your own binding extensions. So that table I showed near the beginning, you can write your own binding extensions as well. And there are some limitations today in terms of there's some features, triggers, and bindings that are only in V1 that haven't yet made their way over to V2. But we're working throughout the rest of this year, and we'll keep working on that list until every trigger or binding that's not an experimental binding that's in V1 will be coming to V2 in the coming months. So if there's something that you're looking for that isn't there yet, there's likely an issue on GitHub where we're tracking that and we're bringing it into V2. So with that, let's show you a little bit about building Azure Functions in this new V2 runtime. And we're going to show you a few different ways to do that. So the first is the CLI. I'm actually going to do this kind of from the bottom up. If you want to use the Azure Functions runtime from the CLI, I mentioned it was available via NPM right now, and it is called the Azure Function Core Tools. Now, if I just left this just how it shows right now, where I'm getting the Azure Functions Core Tools, it's actually going to try to get the V1, the generally available version. So I just need to make sure that I specify I want the .NET Core version, which is that V2 one. So just with that command on this Mac right here, I've installed the Azure Functions Core Tools, and now I can start to run and manage my functions from the command line, whether I want to create new functions or publish them to Azure, whatever else I might want to do. Okay. Now, I'm not going to spend time doing the CLI today, but what I do want to show you quickly are some of the improvements we made to things like the Visual Studio extension. So you'll notice here, now I'm in Visual Studio Code on my Mac, and here I have installed the Azure Functions extension for Visual Studio Code. So this lets me do a lot of things. The first one is I can create a new function app right here from within Visual Studio Code. It's going to ask me where I want that function app. So we'll go ahead here, and I'll just create a new folder called VS Code, and we'll select that folder. And it's going to go ahead and walk me through the experience once I decide to write a new function. So the first parts that I'll mention, and this calls back to some things we saw earlier, this is kind of the initialized empty project that I have here. I see this local settings.json file. Now what this is actually doing here is this is your local application settings. If you remember back to the Azure portal, I showed you the application settings. I had things like the storage account already in there. This is your local version of that, okay? So if you're talking to things like Azure Storage, or if you're talking to things like Event Hubs, this is where all your connection strings are going to go. I also have this host.json file, which allows me to specify any settings on the host. So there's some things like prefetch counts or concurrency controls, all those kind of app behavior things you can do here in the host.json file. I'm not going to do any of that here, but you can check out and learn more on that as you go as well. So now that I have my Azure Function app created, let's go ahead and add a new function to it. And I do want to make sure that I'm connected to my subscription here, because I will want to connect this to a storage account. Okay, it's showing up great. So let's go ahead and create a function. And it's asking what's the app I want to create it in. So I'll just choose the current one. And you'll notice this great experience where it's actually asking me, which trigger do you want to use? This is using the V2 runtime. So this list is a little bit smaller than the V1. And it's even asking me, hey, you need a storage account to run the Azure Functions, because we use a storage account to do things like logs and checkpointing when we read from Event Hubs. So I can go ahead here and say, hey, I have a storage account ready to go. And it's actually connected to my Azure subscription. So I can choose the storage account that I created in the Hello Functions app that we were using earlier. I'll give it a name. And it's asking what's the storage account that I want to listen to for triggers in this case. So I'm going to use just the default Azure Web Job Storage, which I just configured a second ago. And now it's asking what's the blob path, because I've told this I want to trigger on blob events. Maybe I'm uploading a file or a document. So we'll go ahead and change this. I want to listen to the items container, and I want to listen to any TXT file. That's easy enough. So I'll go ahead and push enter here, and you'll notice that the extension has automatically given me some code here to get going. It's configured to my blob. And if I even come back here to like that local settings.json, you'll notice it's populated the connection string for me automatically. The other important piece to know when you're writing node functions is this function.json file. And this is where you can configure your triggers and bindings. So you'll notice that this has automatically already set this up to listen to my blob account. It's going to listen to the connection Azure Web Job Storage, which was in that local settings file. It's going to listen on this path. And this is the name of the field that I want to pass into my method. So I'm not going to go ahead and worry about writing too much code here, but it is worth knowing I could do something like set a breakpoint, go ahead and start the debugger, and all of this extension and everything is going to just perfectly build everything for me. Right now you can see it's making sure that I have the latest version of the Azure Functions runtime. It's starting that function host locally on my machine. And now I'm ready to go. So just to test this out, I'll go ahead and open up that storage account here. And here is that folder that I was listening to. So let's go ahead and just upload a txt file to see this work. Easy enough, hello function.txt, correctly named. And you'll notice here in just about a second, this function locally on my machine picked up that that was there, and I can step through in this point, do whatever debugging I want to do, all from within Visual Studio Code. So that's a quick walkthrough of creating Azure Functions within Visual Studio Code and using that new Azure Functions extension. Now the next piece that I want to go into is the Visual Studio tools. That's actually where I'm going to spend the remainder of this session, is inside the Visual Studio 2017 tools. So let's come back over here, and now we are looking in a Windows machine. I've got Visual Studio 2017 installed. And what's great here is if I want to create an Azure function, and I've installed that cloud workload, I can go ahead and just choose to create a new function right here. I can do, give it a name. I'll just leave it as a simple name right here and say OK. Now you'll notice here, and we kind of mentioned this would come up before, it's actually asking me right now to choose what version of Azure Functions do I want to use inside of this project. So this drop-down is new, and I kind of called out some of the differences before. For this demo, I actually want to listen to Event Hub, so I'm going to leave this as V1, but I could choose V2 and use that .NET Core runtime if I wanted to. What's great here as well is similar to Visual Studio Code, I can either use the storage emulator, or if I wanted to select a storage account in the cloud, I could do that as well. I'll just use the emulator for now, and we'll create a new blank function app. So this is going to go ahead and configure this and get this all set up inside of Visual Studio for us. You'll notice some of those same things that were there before. Here's my local settings file, which are my application settings. I've got my host file. And now if I want to go ahead and add a new Azure function, I can just come in here to add and say new Azure function inside of this app. And I'll just leave this, I'll leave it named function 1 because that's easy enough. And you'll notice here, here's that selection again of some of those different triggers. This is the V1 runtime, so it's a little bit bigger than the V2 one right now. Now a few things I do want to call out, a few gotchas that some people get into. The first here, I've selected I want an Event Hub trigger, and now it's asking me for some fields. It's asking me for a connection, and it's asking me for a path. Now the first gotcha here that I want to talk about is that this connection that it's asking for here is actually the key name to your application settings. So don't paste in your Event Hub connection string here. You just tell it what's the key name that's going to have the connection string in your local settings file or in your application settings file. So I'll just name this my Event Hub for now. The path for Event Hub is actually the name of the Event Hub. So I have one called dev. I have an Event Hub named dev that I want to hook it up to. So I'll go ahead and click OK here. Similar to the Visual Studio Code experience, it's now creating my function app for me. It's kind of created all those pieces that I needed here. Some things worth calling out. Instead of you having to worry about the function.json file for C# functions, you'll notice I actually have here a few attributes. So there's an attribute here letting it know what the function name is. And I also have this attribute letting me know the trigger, the Event Hub path that I want to listen to, and the connection. So this is great because I can just add new bindings just by adding new attributes, and we'll do so in a second. And I need to make sure that I do have this Event Hub key somewhere, because if I tried to run this right now, it's going to spit out an error and say, I don't know what my Event Hub means. So I'm just going to come in here to my local settings file and make sure that I have a corresponding my Event Hub key. And this is now where I can put that connection string. So I've got one here set up and ready to go. Let's make sure I've got my connection strings in this handy dandy notepad file. So this is the Event Hub that I want to listen to. And we'll go ahead and paste that in here. Great. So what this is actually listening to, and I haven't even explained this yet, is I am listening to an Event Hub, but what I'm doing here is I'm actually listening to transactions that are happening. So I care in this function app that we've built, I care about transactions happening in cryptocurrency. So Bitcoin, Ethereum, whatever. I want to be able to process and scale to all of those transactions and do some processing on top of it. So I'm showing here, again in Notepad, so it's not the cleanest thing to look at. This is an example of the type of transaction that I'm going to get. So I'm going to get some transaction. This is from GDAX in this case, which is saying, hey, I've received this transaction. Someone's trying to sell some Bitcoin. I can see what the price of Bitcoin is at this time. I can see how much Bitcoin they're trying to sell. just some information here on the transaction. It's not super important, just kind of the scenario that we're going to work with here. But what I do want to show you here is that in order for me to process this Event Hub data, I can very easily leverage C# classes to do that. So you'll notice right here, right now, we've told it the Event Hub message is going to be a string. And that's fine. I could keep this a string. I could then add like JSON parse and parse the JSON, but I don't have to do that. What I actually want to do here is you'll notice this thing we were looking at before. This is actually a class. So I have a class here called transaction, which is just a plain old C object. And I'm actually going to paste this class directly in this function. So I'm going to say, hey, I have this transaction class, and this has the information that I need. And we'll go ahead and make sure that I'm using system so it knows how to deal with GUIDs and dates and all that fun stuff. Okay? Now what's great here is I know my Event Hub message is a transaction. And instead of me having to parse this by hand, I can actually just change the type right here in the method of my function. So I'm going to say, hey, I'm going to get this thing from Event Hub, which is a transaction, and I want this to be called transaction. And that's all I have to do. So now you'll notice I'm getting a little error here because it was looking for something else. But let's go ahead and change this to output the price of the transaction. So what's great here now is if I go ahead and run this, when messages come into that Event Hub and they are transactions, my function app's going to trigger and run, and it's automatically going to convert it into that transaction class, and everything is just going to work for us automatically. So I actually believe I already have some transactions in this Event Hub that should be triggered here in just a second. But in case I don't, I can go ahead here, and we'll go ahead and trigger in some new transactions. So let's come in here to the Azure portal, and let's fire in some transactions to this one. So I have a simple logic app here, which is just going to add a transaction. And once we add that transaction, you'll see this log will update in just a second, letting us know that we got a new transaction on the Event Hub, assuming I got all my connection strings and everything in there as I wanted to, which I'm hoping I did. So let's go ahead. So we still see job post started. I don't see any errors. Let's come back over here. Oh, I did get a failure here. So something is not happy with my Event Hub processing, but that's okay. I'm not even going to worry about going into this right now, okay? But needless to say, this does push a message into an Event Hub, and it will cast into this transaction object. You don't need to see it run to know that this should work. I probably have multiple competing consumers on this Event Hub as I was testing it out, but that's okay. So I'm running this transaction now. I'm converting it to the method that I want. The last thing I'll show quickly here in Visual Studio is if I do want to work with bindings, I can do it just using those same attributes before. So we've got a lot of documentation on these bindings, but let's say whenever I get a new cryptocurrency transaction, I actually want to output something to a blob. So maybe I have a blog called transactions. I'm just going to leave this as the default storage account right now, but I could configure my own as well. And let's just make this a string called content. So what I've done here is I've written a quick attribute that says, hey, by the way, this function is going to have a string which should go to a blob called transaction. I actually need to give it a file name here, so we'll just name it foo. So container transaction file name foo. And what's great here is in my function, which isn't doing a whole bunch right now, I could come in here and say foo equals, oh, not what I wanted to happen there. Let's say foo, oh no, I'm sorry, it's content. That's why it's not letting me. Content is the name of the string, equals, and we can set this to like transaction dot price is a string as well, okay? So what's going to happen here now, maybe it is not a string. Let's go ahead and add in, we'll just do price to string, why not? We can make everything a string, okay? So now what's going to happen when this function runs is it's going to still trigger on that Event Hub, but then I'm also going to output to a blob of my choice. So you can use those output bindings as you want. You can add multiple output bindings as you might need. There's some strategies around doing that, some documentation, which I won't get into now. So that's a quick run through of some of the different tools that we have to help you in building those Azure functions in a number of different tools. So for the next part, as we kind of finish up on this walkthrough of Azure functions and the different ways that you can build them, I do want to talk about some of the ways that you can deploy and monitor these functions. So we have a bunch of different options for you to do that. You can deploy directly from Visual Studio. You can deploy from the function command line interface. Visual Studio Team Services has a number of templates out of the box to set up a rich continuous integration platform. You can use ARM templates if you're familiar with that. If you're writing your functions in Java, we have Maven and Jenkins tooling as well. So really whatever you want to use to deploy your functions, we probably have tools to make it possible. And the other aspect, which we've talked about some, is on monitoring your Azure function. I called out that Azure App Insights toggle when we created our function, and I'll show you a little bit about some of the power that you get from enabling that. We do provide like that log that I showed you when we ran the Hello World one. So there's a function log that's there. I would say though, Application Insights is going to have a lot more information. And the other aspect with our log is we don't retain that for a very long time. So don't rely on the function log to be the thing that you're going to look at to go diagnose an incident or some type of bug that might have been into your system. I would recommend using Azure App Insights to do just that. And it is also worth noting that we are working on support for the Azure Monitor service. So if you're familiar with Azure Monitor with any of your other resources, shortly you'll be able to use Azure Monitor to monitor metrics and diagnostics from your function app. So let's go ahead quickly now and let's go back to this function that we wrote ahead of time. And I just want to show you how easy this would be to set up something like a continuous integration pipeline for a function. So I'm going to go ahead here in Team Explorer and let's go ahead and commit this function app into source control. So I'll say my demo that didn't trigger, which is fine. We'll go ahead and commit that. And I can sync this now with the remote source control system that I might want. Now I love Visual Studio Team Services. It's super great. I get as many private repositories as I want. So let's go ahead and publish that there. And you'll see I've connected. Oh, I actually do want to use this login. I'm connected to Visual Studio Team Services for my account. And it's looking right now at my account and it's seeing the different projects and repositories that I already have. And let's just go ahead and name this Connect Live. Okay? And let's publish this to that Visual Studio Team Services account now. So now I have this code checked into source control. I can start managing commits and making sure that as I make changes across my different branches or my different team, that everything is managed for me in Visual Studio Team Services. And now what I want to do after this is done publishing the code is I want to set up an automatic continuous integration pipeline. So what I want to have happen is that if I ever make any changes to this Azure function, I want those changes to automatically go and propagate into the different systems that I'm using. So let's go ahead and open up this Visual Studio Team Services account that we just created. And here now is our Azure function project. It's all here ready to go. And this is super easy. Let me go ahead and zoom in here as well to make sure that you can see it okay. So I can come in here to Visual Studio and I can go ahead and set up a build to happen on this code branch. So let's go ahead and set up a build now. And all I have to do is say, hey, this is an ASP.NET core application. Even if this is using the function v1 runtime, this template still works great. Let's go ahead and apply that template. And make sure if you're doing this, though, that you do set up the VS 2017 build agent. You do need to be using the VS 2017 build agent for this to work correctly. But all this is going to do is whenever this build process gets triggered, it's going to download any NuGet packages that you might be doing. It's going to build your solution, run any tests that you might have defined, and go ahead and publish this so it's ready for release. Okay? So I don't even have to make any changes here. In fact, the only change I'm going to make is I do want this to trigger automatically whenever I push something to my master branch. So I'm going to say, hey, I want continuous integration, so go ahead and set up that trigger. So I can go ahead and save this now and queue it up to go ahead and build the solution. And now anytime I make a change on this Azure function and push that change to my master branch, this build process is going to kick off and automatically build my function. Now, let's say I want to release this function. Now it's built and I want to go publish it into some Azure subscriptions. Maybe I have a dev subscription or a production account or a production function. And that's super easy too. So while this is building, let's go ahead here and, oh, not what I wanted to do. Come in here to the releases section for Visual Studio Team Services. And here I can go ahead and define a new release, which will go and publish whatever just got built into Azure. So I can publish this to Azure Functions or publish this to wherever I want my function to run. So here as well, I can use the app service deployment template, which works for function apps. So we'll go ahead and apply that here. and we'll just deploy this to a dev environment, which I'll configure in just a second. So that's it. I can now kind of go and build out my different environments. It's asking what I want to actually release. So I'll go ahead here and say, hey, why don't you release the thing that gets built from the build definition we just created? And I can go ahead even here and turn on continuous deployment so that this thing will release it whenever a build completes. Okay? So now whenever a build completes, it's going to kick off this process and deploy it into my dev environment. Now, in order to configure what your dev environment is, you can see it's a pretty simple step. It's just deploy this Azure App Service. I just have to choose the Azure subscription that I want to deploy this to. In this case, I'll just select the top one and authorize this project to go and use that subscription. And once it's authorized, I just select the app service that I want to publish it to. And that's it. So now I click Save here in this process. This can take a minute or two to authorize as it creates that service principal account. But just that easily now, if I come in here, once I finish connecting this and configuring this, if I came in here and made a change, like instead of the price, maybe I wanted to output the, the order ID to blob, I could go ahead and make that change, check it into source control, change to order ID, commit it, and behind the scenes now, it's gone ahead and kicked off this process. I'll go ahead and finish configuring this now too, so it works end to end. And let's go ahead and I think I have one that I know is a safe one to publish to, which is called delete me. So you always know that's a safe one. So now we've gone ahead and we'll save this release process. Let me make sure it's saved. And so now behind the scenes, I can even come here to build because I made that change. And you notice here that that build has succeeded already for this one. I need to sync this code change to push this to the cloud. So this change to order ID. And what you'll see here back in Visual Studio Team Services is that it's automatically kicked off this build, changing it to order ID. And once that build's done, it's going to go ahead and release it into my Azure subscription. So that took, what, like 2-3 minutes, starting from scratch, a brand new project. And that's how quickly you can get some of these build processes set up and running for you. Okay, so that's kind of a good recap of that end-to-end. I do actually want to talk about monitoring your function app very quickly. So we have now this function that we've written, the one that monitors Bitcoin transactions, but I actually haven't really done much with it. In fact, the one I developed locally didn't even trigger the way I wanted it to. So I do want to show you here, if I come here to the Azure portal, I actually have one that I published just a little bit ago, which is the same function app. It's listening to messages from Event Hub, waiting to get transaction information on Bitcoin or Ethereum. I do some analysis on that transaction. I see how much monetary value is being handled, and then I output to blobs as I need. Now what I actually want to do is I want to turn this on. I'm going to go ahead and run a simple application here. So let me go ahead and open this up, and I'll show you just how simple this application really is. All this app is doing is it is running on top. Let's get this out of the way. I'm running on top of the GDAX network, and I'm looking at every single transaction happening right now while I am recording this for Bitcoin or Ethereum, and I'm going to publish that to an Event Hub. So there's not a whole bunch of code running, but let's go ahead and do that now to start publishing all these events happening. And just so you know, like in case you're not familiar with Bitcoin or Ethereum, you've probably heard those names thrown around. This list down here is moving very fast. There's about 400 transactions happening every single second across those two networks. So I've just started pushing a bunch of that information into Event Hubs. And what I have here is that function app that I published ahead of time, which is spinning up right now and listening to those events that are happening in real time. So you'll notice here, this is Azure Application Insights. And this is that tool that when I toggle on, I can use. I've done nothing here except for toggled that thing on. And I can come in here and I can start to get information like live metrics. So this is actually going to give me a live heartbeat of what this function is doing as I'm sending these hundreds of events to this function app. You'll notice right now, at the time I'm recording this, there's about 121 transactions happening every single second. I can see how my function instance is handling that load. And you'll actually notice as I hang out here for a second or two, if this reaches a certain threshold where that instance is getting close to 100%, the Azure Functions are actually going to automatically scale to multiple instances for me automatically. So it doesn't look like it's had to do that yet. We're at about 250 a second. Not as many people buying things on Bitcoin right now as they need to for it to scale. But if this thing ever started hitting a threshold where it couldn't handle the load, you could actually watch this span multiple servers without me even had to make any changes. So that's really cool that I get that type of insight. I can see the logs that I can emit. I can see my latency here as well. That's all great. The last thing I want to show you here in Application Insights is that I can do analytics on top of my Application Insights as well. So this enables me to do some really rich queries on top of the data. So just to give you an example of that here, and I'll zoom in a little bit as well, you'll notice I have all these tables for my function app that I can listen to. In this case, let's look at every single request that is coming to this function, which in this case is a transaction. And I actually can summarize this, and let's figure out what the latency is. I want to know how my function app is performing, how long does it take to execute and evaluate a single Bitcoin transaction. So we'll go ahead and pass in the duration. And I'll say, you know what, I want to know what's the 50th percentile for latency, what's the 75th percentile, 90th percentile, and 99th percentile. So we'll go ahead here and run this query. And in just a second, you'll notice how quick that was. Here's that data from this function app that I'm running now on Bitcoin transactions. You can see in the 50th percentile, it only takes about 160 milliseconds for that function to spin up and execute. And my 99th percentile, looks like I've got a function execution there that took about 1.5 seconds, 2 seconds. So I have these rich tools available to me to monitor my function app that you should definitely be taking advantage of. Okay, to wrap things up now, I want to talk about one more aspect which is new to Azure Functions that you should definitely know about. And that is how you can orchestrate functions and orchestrate function processes. So there's really two tools here that you should know about. One of them is Azure Logic Apps. This has been around for a while. It's a generally available service in Azure, which allows you to create rich orchestration and integrations to work in the serverless space. So if you're not familiar with Logic Apps, I'd recommend checking out one of the other sessions or videos on it. I'm not going to go deep into it here, but it is a codeless orchestrator that enables you to manage state and data across different function apps. So maybe something happens like, hey, an order has happened, and now I need to go send an email, charge their credit card. You know, there's a bunch of steps that have to happen. Logic Apps is one way that I can do to orchestrate those different functions. The second way is a new one. Just in preview now, we just announced it a few weeks ago, which is called Durable Functions. And this is codeful orchestration. You can actually build these directly within Visual Studio, and I'll show you a simple hello world here in just a second. But this enables you to do not just function orchestration, but it actually provides some really rich patterns. So one of my favorite ones here is like fan out and fan in. I just got off the phone with a customer before coming here, and they were getting some information from Cosmos DB. And whenever they get a record from Cosmos DB, they want to spin out a bunch of parallel functions to process every single line item in that document. And when every single line item has been processed, they want to aggregate the results. Now, doing something that complex as fanning out and fanning in becomes fairly trivial with things like durable functions, as well as function chaining, or some long-running function processes. Maybe you're calling multiple functions and it takes 30 minutes for the whole chain to complete. Durable can manage the state for you. So it would be helpful if you're getting into durable functions to kind of understand what's happening behind the scenes. So this is a quick diagram of how durable functions works. You have your Azure function, which just runs. This can be just like those functions that we've just been running here today. HTTP triggered, Event Hub triggered. Some function then needs to say, hey, go ahead and start this orchestration. So you'll have a function that goes and starts an orchestrator function, which is a function that's very special, specifically for orchestrating this process. And that orchestrator might call a number of different activity functions, either in parallel or sequentially, waiting for human intervention, whatever that orchestration is. And what's great here is that your orchestrator function actually exposes a status endpoint so that you can check status or get the end results of that orchestration once it is completed. So very quickly here, just to finish, I do want to show you creating a durable function. So I'm going to go ahead and create here a brand new function project because I do want to use the v2 runtime here. So let's go ahead and quickly create a function project, and we'll choose v2. And in this case, for this second function project, let's make sure I set this as the startup project. I always forget that for demos. Let's go ahead and add in a new function here. And you'll notice here my list is a little bit smaller, but the ones I want to call out here, one of these templates is for doing your starter activity. So this is just a trigger-based function that will go start an orchestrator. I can also have an orchestrator, which is that special function, and an activity. So here we're going to do a really simple durable function orchestration, which is just going to go call a function multiple times and then return the output. So first let's get that starter function and drop it into our project. And I'll show you just quickly here what that's made up of. So I'm getting that HTTP trigger, and you'll see here I also have this special binding, which is my orchestrator client. And here, all it's going to do is it's actually going to get some content, but I actually don't even need to send content, so I'll go ahead and comment that out. And it's going to call whatever function we tell it to in the path. So you'll notice here I've actually defined a custom route to invoke this function. I'm going to get a function name, and that's the orchestrator function that I'm going to invoke. So I'm going to have an orchestrator function that this function is then going to invoke, but I haven't created it yet. So let's create the orchestrator function. What orchestration am I actually going to kick off? So let's go ahead here, and we'll create that orchestrator. Again, a quick template that I can get started with. In this case, it's called function2. Let's actually just call this cities, because I think that's what I'm going to have it do. And all this orchestrator function is going to do is call a function called hello, and it's going to pass it the data Tokyo, and then it's going to call a function called hello, and it's going to pass the data Seattle, and call a function called hello and pass it the data London. Now I could come in here as well and make my orchestrator a little bit more advanced, like with some for loops and some parallel task wait for all things, but let's just keep it simple. Let's just call this function called hello, pass it Tokyo, hello Seattle, hello London. Now the last thing I need to do is I actually need to make sure I have a hello function there, which I don't yet. So let's create one more function, and this will be called my activity function. And these are the functions my orchestrator is calling. And let's make sure we call this hello. And you can see all it's doing is echoing back hello. Okay? So that's it. So that's what I need to do a durable function. I've got my triggering function, which is going to start this orchestrator that's going to just call hello to those different things. So quickly here, let's just go ahead and run this function app. And it should expose for us this local endpoint so that I can test my function locally and invoke this trigger. You'll see here it gave me that right here. So we'll grab that URL and open up handy dandy Postman. And let's replace function name with cities is what I called it. Okay. So let's go ahead and do that. And that has gone ahead and kicked off my orchestration for me. And you'll notice it didn't actually send back the hello different cities because it had to go spin off this orchestrator process, which could take a long time. So it's actually given me a URL to check the status, a URL if I want to post events to that orchestrator. Maybe I have to wait for human intervention, and a URL where I could terminate it. Let's go ahead here and just look at the status one because it should be done. It's not doing anything complicated. And you'll notice here that the status was completed successfully. It called that function 3 times, and everything happened as I wanted to. So definitely an advanced feature here, but very, very powerful if you're looking to do function orchestration. And I would recommend, if this is something that you're interested in, check out a number of the quick start tutorials on the documentation page. There's some there to do this sample I did. We have one where you can build a serverless 2-factor auth site so that it sends someone a text message that they have to respond back with the code. So you have some human intervention there as well. All right, so that's the content that I wanted to share with you today. We'll just wrap it up with this call to action. So if you haven't yet built an Azure function, first and foremost, go try Azure Functions today. If you don't have an Azure subscription, you can actually follow this URL here, which will get you started with an Azure function even without a subscription, so you can start playing with it and finding some of the benefit. Definitely check out one of the quick start tutorials. We've got about 7 or 8. Everything from processing data from Twitter to 2-factor auth to resizing images. It's all there. Check it out. Go build it. Try this out. What's cool about serverless is that you can just spend a few minutes or an hour and have some really cool stuff up in the cloud ready to scale to millions of events. If you want to stay informed with updates from myself and our team, you can reach out to us on Twitter at Azure Functions. And definitely stick around Channel 9. Look at the other content coming around Connect. to learn more and continue to understand more of some of the powerful stuff that's coming out of Azure. So thank you very much for joining. Hopefully this was helpful. Feel free to reach out to me if you have any questions, and I look forward to seeing what you all build with Azure Functions. Thanks so much.